Let's find the derivative of this equation. And at first glance, it may look pretty simple, but in fact, we're going to need to learn something new called the chain rule. Now, the chain rule is when we have essentially a composite of two functions. So here, technically, I have the square root of x and then 4x cubed minus 5. 4x cubed as a composite would go into the square root of x, creating our equation. So what you do now is categorize the two functions. We have our outside function and our inside function. And if you have a hard time figuring out which one is which, the inside function is what you would do first if you were simplifying, and the outside function is the operation you would do last if you were simplifying. So to take the derivative of this equation, we're going to take the derivative of the outside function, keeping the inside function the same, and then multiplying that by the derivative of the inside function. So now let's take this step by step. Let's take the derivative of the outside function, which we said was the square root, and we can rewrite that as x to the 1/2, and then applying our basic derivative rules, we get 1/2 x to the negative 1/2. Now your inside function stays the same, so normally under the radical we would have the 4x cubed minus 5. So we're going to put the 4x cubed minus 5 back inside the outside function. So we now have 1/2 times 4x cubed minus 5 raised to the negative 1/2. Now we'll move on to finding the derivative of the inside function, our 4x cubed minus 5. So again, following basic derivative rules, we get 12x squared. The minus 5 is gone now because the derivative of a constant is 0. And we can include that in our final answer. Now, normally at this point, we would rearrange a little bit and get rid of that negative exponent, but I think this is enough for now. We're just going to stop right there, and you can check back later for more.